Hey everyone, in this video we're going to talk about section 2.4a, which is titled Trigonometry Extended, the Circular Functions. So far in this unit, we've been talking a lot about things that you did a couple of years ago in geometry. So pre-calculus takes all of those topics that you learned previously, but now we're going to start applying them on the coordinate plane. So for instance, I have a coordinate plane right here. I have my x-axis and I have my y-axis. What this diagram shows is really this ray here that's forming an angle with the x-axis, okay? And I can see the arc of this angle illustrated here. Okay, so there's a couple of different vocabulary words that we need to know and have ready to go, okay? So first of all, when we're looking at our angle, hello, why are we not drawing? Okay, when we are looking at our angle is always going to start forming from the x-axis, and we're going to go either clockwise or we're going to go counterclockwise, okay? Whenever we are going counterclockwise, those are going to be when we have positive angles formed, versus if we go clockwise, we're going to have negative angles formed, okay? So counterclockwise is positive, clockwise is negative. And so when we are doing this, we're imagining that we have this ray that is sweeping out starting from the x-axis. So we're going to call that x-axis, or this part of our angle, the initial side, as that is where it starts. Okay, the terminal side is where that ray ends up. And then the point of intersection, or where that origin is the vertex. Okay, so our ray is going to sweep out either clockwise or counterclockwise, and it's going to end somewhere, and that forms some sort of angle, okay? So back in geometry, you should have learned how we can start partitioning out that coordinate plane, okay? Thinking about kind of like when you did rotations during your transformations unit. So for instance, I know that if I start here, okay, we're gonna start at our initial side, start at our x-axis, and I rotate up into where we hit our y-axis, well, that's gonna be 90 degrees, right? Then if I go down to the x-axis again, that's going to be 180 degrees. Then going around down here is going to be 270 degrees. And then back to where we started is that full 360. The thing that we need to keep in mind is that when we are starting somewhere, that start is really 0 degrees, okay? So there's that. If we were to go clockwise, okay, we went counterclockwise first. If I went clockwise, well, down here is going to be negative 90 degrees. Okay, coming back up to the x-axis is going to be negative 180 degrees. Coming back up here is going to be negative 270 degrees. And coming back down around here is going to be negative 360 degrees, okay? Knowing that, you know, the full circle all the way around in degrees is 360, okay? So if you go break it up into the 4 quadrants, that's 90 degrees each time. With this, I can see here that I can go either clockwise or counterclockwise, and I can actually end up in the same place, right? So I know that going counterclockwise 90 is really the same thing as going clockwise negative 270. So that's what is going to lead us into our definition of coterminal angles. Okay, so coterminal angles are generated by the same placement of the initial and terminal rays, meaning that there's going to be a lot of different angles that we can have that's actually going to end us up in the same place. Like, for instance, let's say that I went 720 degrees. Well, what is that going to be? Well, 720 would be going around counterclockwise twice, and that's still going to end me up in the same place as 0, as 360, and even negative 360, okay? So that's what we're going to do down here in these 2 examples. So in these examples, we are given a bunch of different little angles here, okay? And our goal is to identify the angle that is not coterminal with the other angles. So basically, we need to identify which angle does not end up in the same place. Okay, so first, my first angle here is going to be 440. And let me just say, I'm going to be using some colors to color code this, so if you want to grab out some highlighters, some different colors, absolutely go for it, okay? If not, that's fine as well. Okay, so 440. Well, I know that a full circle all the way around is 360 degrees. So what I might start thinking about is, well, with 440, how much is added onto 360 after that? Basically, like how many full circles am I going to make, and what's my remainder going to be within this, okay? So 440, I know is going to be 360 plus, it's looking like 80 degrees, okay? So that means that for this angle here, okay, I am going to start from my 0 degrees, okay? And I'm going to go around 360 degrees, and then I'm going to stop when we get to 80, okay? And I'm just going to do my best to illustrate this, but I'm guessing that we end up here at 80 degrees, okay? So this red represents my 440. Let's go negative 280 this time, okay? So in this case, I know that because I'm not going positive, well, there's no 360 that ends up in negative 280. But let's maybe use our idea of these different quadrants or our different placements from the axes to help us figure out where we're going to be. So I know that if I go, how do I want to think about this? Well, going clockwise, there we go. This is going to be negative 90. Right here is going to be, let me do this, maybe off to the side. Negative 90, negative 180. Okay, this gets me to negative 270, but I want to be at negative 280. So I think that's going to be negative 270 minus another 10 degrees, which boop, 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 is going to end me up right here. Okay, so that's where my negative 280 ends up. Okay. Let's do 80 degrees. Well, 80 degrees I know is starting at 0, and I'm going 80 degrees. So we're there as well. It's great for us. Okay, running out of colors quickly. Let's go to blue. Let's see, 460. Okay, so again, that's going to be positive. Let's think about this maybe in terms of 360. That's going to be 360 plus 100. Okay, so that means that I'm going to make my full circle all the way around. Okay, here's my 360, and I need to go 100 degrees. So I'm going to keep going. Here's 90, and then my 100 is going to be just 10 more after that. So I think that we end up here. Okay. I can already see right now that I did not end up in the same place as the other one, so I am going to go ahead and circle 460 because I don't think that it is coterminal. Okay, we ended up in a different place, but we do have one last angle that we need to check. There could be multiple answers. I don't even know. Okay, the last one is 800, so let's figure out how many 360s go into this since this is positive. Well, I know that 720 is 360 times 2, so I have 360 plus 360, okay? So that's 720. And then how much more to 800? Let's see, 720. I think I need another 80, which this looks good news for us. So we're going to go around. Here's 360. Here's 720. And I need that 80. And I do see we end up in the same place. So I think that our one angle that is not coterminal with all the other ones, which one is not like the other, that's going to be our 460 degrees. Okay. Example B is very similar, however, the difference here is radians. And like I've mentioned before, most of the work that we do in pre-calculus is going to be radians. So I do want to do this example here as well. Okay, so first of all, now that we're not in degrees, we now need to kind of redefine what each of our axes stand for. Like just before, you know, our axes started at 0, 90, 180, 270, things like that. I've mentioned this before, but we can definitely recalculate it. But 180 degrees is equal to pi radians. Okay, and we can actually prove that using our formula that we had to convert from degrees to radians. I know that I'm going to take my degree amount, which is 180, and then to turn it into radians, I'm going to multiply by pi over 180, which I do see is going to end up with pi, okay? So in this case, 0 is going to be where I start. Okay, that's our starting point, 0 radians. 180 is going to be pi. And so that means that if I go, 360 degrees, well, that's going to get me to 2 pi. Now with that, if we think about this 180 here being pi, well, what's that going to make this axis? Well, it's going to be pi over 2, right? Like half of pi. Similarly, what's this one going to be? Well, it's half of pi more than pi. So pi plus pi over 2, which I think is going to be 3 pi over 2. Okay, so that's this axis, 3 pi over 2. Okay, let's see where we're at. We, though, are dealing with all of our measurements, it looks like, are in terms of pi over 3. Okay, so in this case, we just want to split up each half quadrant, or like each half, like the upper half and the bottom half, in terms of thirds. Okay, and we're going to just kind of do our best. So maybe like this, like where this is a third, this is a third, and this is a third. Okay, and then that means I need to do the same thing down below. Oh, we're in erase mode. Okay, I'm gonna erase these little things here. Okay, because we've split them up into thirds, let's just go ahead though and just label them. So this is gonna be pi over 3. Okay, this next one's gonna be 2 pi over 3. With this pi here, I can think about this as 3 pi over 3, which I do know reduces down to pi. Okay, we're gonna have 4 pi over 3, 5 pi over 3, and then if I add one more pi over 3, that's gonna be 6 pi over 3, which is good news for us because that does reduce down to 2 pi. Okay, so we have gone through and labeled all of these. So now we need to figure out which one of these radian angles is not coterminal with the others. So let's start with 4 pi over 3. Okay, well, I know I'm going to start at 0, and we are going to go around to 4 pi over 3. Okay, so we end up here. Okay, if I go negative 4 pi over 3, well, that just means that I'm going to count, but I'm going to go clockwise this time. Okay, so here's my 1 pi over 3, 2 pi over 3. Nope, that is not 2 pi over 3, that's 3 pi over 2. Hopefully you caught that. Okay, 1 pi over 3 is here, 2 pi over 3, 3 pi over 3, and so that means that here this is negative 4 pi over 3. So we went around to here. Okay, so I can already tell right now here that one of these is not going to be coterminal. We just need to see where the other ones end up. Okay, switching colors. Let's see, we're going to do 2 pi over 3. So we're going to start at 0, and we're going to go to 2 pi over 3. That's going to end me up right here. All right, next up we have negative 10 pi over 3, so I know that I'm going to go clockwise. So 1 pi over 3, or negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3, negative 6 pi over 3, negative 7 pi over 3, negative 8 pi over 3, negative 9 pi over 3, and finally we're back here at negative 10 pi over 3. So geez, how many times do we go around? We're around it once, and back to here. Okay, last one, let's see, I need one more color. What should we do? Pink is good. We're going to do 8 pi over 3, okay? So first of all, you could count around each time, right? Go in the circle and go around. But in this case, if I know that 2 pi is really 6 pi over 3, well, let's just figure out how many more pi over 3s we need to add on to get me there. So in this case, I'm going to think about this as 6 pi over 3. Okay, that would be a 1 full turn around, okay? Plus, I need 2 pi over 3 more. Excuse me. So start here. Here's our 2 pi over 3. No, those are 6 pi over 3, and then our 2 pi over 3 ends us back up here. So I think that the first one that was non-coterminal with the others was actually the very first one. 4 pi over 3 lands you in a different place. Okay. When you're ready, let's go ahead and flip over our page. We are going to look at one more example here. We are going to evaluate the 6 trig functions with this point. So we have this point 5, negative 1. Okay, and before, when we were always evaluating these trig functions, we always had a right triangle that was given to us. Well, in this case, we're going to have to draw the triangle ourselves, okay? So what we're going to do is we are going to drop down a leg and create a 90-degree angle with the x-axis, okay? So whenever we make these triangles, it's always going to come from the x-axis. So like, let's say, for instance, here, that I have this point up here. Well, in this case, okay, here's our, it connects to the vertex. We're always going to drop it down here, okay? So here we go. So for this, I know that I need to know all of the legs of my triangle, okay? So we're going to use this point in order to do so. So here, since my x-coordinate is, here, let me write this bigger, it's kind of small. This point is -5, or 5, -1. Okay, so our x-coordinate is 5 and our y-coordinate is -1. So in this case, this leg on the x-axis is going to be 5, and then this leg down here, that's down below, is -1. Now I know what you're thinking. You're like, well, we can't have negative side lengths of a triangle. In this case, now that we're on the coordinate plane, we actually can, okay? Because we're not talking about a standalone triangle. We're talking about a triangle that is formed by this point, okay? And so that negative is going to be important. So throw out everything that you thought you knew about a triangle, okay? We can have negative legs now. In order to find the hypotenuse, which we're actually going to call, well, we'll talk about that in a second. In order to find our hypotenuse, we need to use the Pythagorean theorem. So here we go. I'm going to have 5 squared plus -1 squared. We can say it's equal to c squared or h squared. In this case, let's go ahead and call this r, okay? Because eventually what we're going to do is we're going to call this side length our radius. Something to ponder. Okay, so we need to find the length of that radius. So let's see. 25 plus 1 equals r squared. We'll have 26 equals r squared. We're going to take the square root of both sides. Again, I know that we can have plus or minus. In this case, when we are finding this length, I know we can just, I just said we can have negative side lengths. In this case, though, this radius or this hypotenuse will always be positive. So we are going to keep that as positive square root of 26, which I do not think simplifies. So we're going to leave it like that. Okay, so now we need to identify all of our trig functions. So this is very, very small, but our reference angle is going to be right in here, okay? So that's going to make -1 our opposite, 5 is our adjacent, and our hypotenuse is going to be that square root of 26. So here we go. We know that sine is opposite over hypotenuse, so that's going to be -1 over the square root of 26. We know that cosecant is just the reciprocal of that, so hypotenuse over opposite, so we'll have square root of 26 over -1, which we can just call negative square root of 26. Cosine is adjacent over hypotenuse, so that will be 5 over the square root of 26. And secant is just the reciprocal of that, so hypotenuse over adjacent. So we'll have square root of 26 over 5. And the tangent is going to be opposite over adjacent, which is -1 over 5. And cotangent is the reciprocal of that, so adjacent over opposite. So we will have -5 over 1, which we can just call -5. Okay, cool. I think we are going to pause here for now because I would like to do this concept 3 or these next 2 examples, A and B, in class together. So where we are going for this is we're eventually going to want to be given a point, and we're going to want to be able to identify our trig ratios for all of that, okay? So hold off on doing these examples, we'll do them together, but that is all for this video, and I will see y'all later.